Everyone. Today we're going to continue our discussion about logarithms. We learned last time that logarithms are the inverse to exponential functions. We're going to learn some properties of logarithms today, how to take two logarithms and combine them if they're separated by addition or subtraction, and learn three specific rules, actually probably four rules that are specific to logarithms. So I'll start with a warm-up. Okay, practice our conversion from exponentials to logarithms. Okay, for the first one, rewrite it as a log and then check that you can take that log in your calculator and get me an answer. And for the second one, graph the log. Maybe we'll also want to convert that to an exponential. Go ahead, pause the video, take some time. When you're ready, unpause, and we'll continue. Okay, so hopefully you tried it out. It wasn't too much trouble for you. Okay, this one had a base of 10, the top one, so log base 10 of 5,280 equals y. We can put base 10 into our calculator, so we just do log of 5280, and we get about 3.723. And the second one, we can convert 2 to the y equals x plus 4, or we could do 2 to the y minus 4 equals x. And in this case, I picked a few values for y that I know, and then I can get some x values. So if I put a 0 in for y, I got -3 out for x, so -3 is 0. And if I put a 3 in for y, I can get, make a table. So the values I said we normally pick are those. We put them into the equation and get an x value. So if I put in 1, 2 to the first is 2, minus 4 is -2, so I have -2 comma 1. Put in 0, 2 to the 0 is 1, minus 4 is -3. Put -1, I would get -7/2. Okay, and two of those points are nice to graph. And then the 4 tells me that I have a vertical asymptote right here. So moving on today, more about logarithms. Today we're going to talk about the product property, the quotient property, and the power property, which are all properties that allow us to rewrite logarithms in different forms, simplify, and solve. Each property is going to be used in a specific spot. So we're going to do some exploring here. You need your calculator for this. I want you to find a single logarithm that's equivalent to each of the following statements. So I want you to put log of 5 plus log of 6 in your calculator and get me a decimal. And then I want you to figure out what goes in the question mark. Is it log 7? Maybe log 5 plus log 6 equals log 7. Maybe it's something else. Try to see what the pattern is and see if you can extend the pattern. And then what if it was log of A plus log C? Then do the same thing for subtraction. Pause the video, take your time, figure out what would go in each question mark. Okay, so you're just beginning to get them probably. Maybe you got the first one as log of 30. Log of 5 plus log of 6 equals log 30. It'll be the same decimal. Now you start expanding and saying, okay, log 8 plus log of 11 equals log of 88. You might have tried log of 19, but that doesn't work. So you have log of 88, and log of 7 plus log of 7 is log 49. And if you try a few of these, you may have figured out the rule, log of A plus log of C is log of A times C. We can multiply the two arguments and get one new argument. The base does not change. Now try subtraction. Pause the video if you want. Think of what you think the rule might be. Test it out. Always test out our ideas. That's how mathematical learning takes place. Okay, you tested it out. You got log of 14 minus log of 2. Hopefully you got log of 7. If you put log of 12, then you didn't test it out. Because my first thought was to do 14 minus 2, but when I put it in, they get different decimals, so that's a problem. So I test out a few more cases and see log of 36 minus log of 3 equals log of 12. The decimals are equivalent. Log of 25 minus log of 5 is log of 5. The decimals are equivalent. And I could see that if I subtract two logs, I can divide the arguments. So I can do A divided by C, 25 divided by 5, 36 divided by 3, and get one log instead of two. And condensing logs, combining them, making them one single log is going to make it much easier to deal with when we get to a multi-step problem. So these are called the product property and the quotient property. The product property says if they have the same base, so the base in the last problem was always 10, the base could be anything. As long as the base is the same, we can multiply the arguments. So we take A and multiply by C. And the quotient, same thing. If we see subtraction, we take A divided by C. And when we get to solving, we're going to see how these rules really help us to condense parts of equations and make it look, for lack of a better word, cleaner. Now, the next rule is my favorite rule. Probably because it's the most useful. I've seen it as many times, if not more than every other rule combined. Okay, so let's look. Let's say we have the log of something plus the log of something. We've learned now, according to the rule, that we can take A and multiply by A and get A squared. But we also know if we have something plus the same thing, for example, if I have X plus X, I have 2X. So log of A plus log of A is 2 log of A. So these two different results are really equivalent. So this 2 and this 2, so the 2 in the exponent and the 2 as the coefficient are the same. So when we are rewriting logs, if there's an exponent, we can write it as the coefficient. And that's what the power property says. If we have log of A to the x really can be a multiplier, so we have x times log of A. That's going to be really, really important when we have to rewrite to get the x out of the variable, the x out of the exponent. Okay, we don't want variables in as exponents, so we can move it out front and then use operations that we've used in the past to help solve for x. So those are the three properties. There's two other properties that are pretty interesting. If the base and the argument are the same, this is really saying b to what power is b. So when this b matches this b, the base matches the argument, the answer is always 1. And when the argument's 1, the answer is always 0. Okay, I can have log base 237 of 1, and I know that equals 0. Because 237 to the 0 power is 1. Same thing here. Log base 237 of 237 is 1. Because 237 to the first power is 237. Those are rules I don't remember as much. I just convert them to exponentials. The top three, though, are going to be super helpful when solving and simplifying. Now, I want you to try these 6 out, or try as many of these out as you feel is necessary for you to understand this topic. Some of them start as a single log, and I want you to split it up into multiple logarithms. Some of these have 2 logs or 3 logs. I want you to condense it into a single logarithm. So if it's multiple logs, let's convert it to 1 log. If it's 1 log, let's convert it to multiple. Pause the video, take 5, 6, 7 minutes, try them out, show yourself that you can use all these new rules that we've learned. Okay, let's take a look at them. Okay, there's the answers. Pause the video if you want to check each one. If there's a specific one that you're not sure what mistake you made, look at each step. Okay, the exponents become the coefficient. Division means subtraction. Addition means multiplication. We can go back and forth because sometimes we're going to want to split the log up, and sometimes we're going to take the logs and make them into one. Now, the last topic we're going to learn about is what does our calculator like and what does our calculator not like. So, log base 4 of 25. Try to put it in your calculator. I don't think you're going to have much luck. Think about what is the problem? Why can't I do that? Well, if I try to type in my calculator, there's a number of problems. I can type log of 4 with an imaginary base or no number down here. I type log of 25. The standard base is 10. So if this was a 10, if this little 4 was a 10, then I have no problem. Put it right in the calculator, it'll give me a decimal. So we need to convert log base 4 of 25 into a problem where there's no 4 here, there's a 10. We're going to learn how to do that. Okay, that's called change of base. So we're about to learn how to change the base of a logarithm. So we're going to have a few steps on how we do this. Okay, and this is going to help us next lesson as well, how to solve a problem that has a log in it. So step one, when I see a problem and I want to know what it's equal to x. It's equal to a variable. I don't know what it's equal to, but if I can find x, I can figure out what the decimal is. Now, step two, we've been practicing this a lot. If it's a log, I can write it as an exponential. So there it is as an exponential. 4 to the x equals 25. Now, the third step is going to be kind of new to us because we never knew we could do this. But the reason why we learn about logs is to solve when there's a variable in the exponent. So I'm going to take the log of both sides. And that may look goofy right now, but you'll see why momentarily that actually makes a lot of sense and it really helps us to solve. Because step 4 says take the power property, which means we can move that x out front. So we have x times log of 4 equals log of 25. And now if you notice, both my logs are in base 10. And I just have to solve for x. So I got to do one division here. So I got to divide both sides by log of 4. So x equals log of 25 divided by log of 4. They're both in base 10. And that is my answer. So I have log base 4 of 25 equals log of 25 divided by log 4. Doesn't look super pretty, but at least I can calculate that. I can use my calculator if I need a decimal. So now you're going to try a few. So I want you to write this as 2 logs. Okay, write it in base 10. Now, if you see a shortcut, test it out. If not, use the 5 steps we just showed on the previous slide. Pause the video, take your time, and get to the correct answer. Okay, so you've tried it out. And hopefully, for the first one, you got log base 2 of 12 equals log of 12 divided by log of 2. And for the second one, log base 3 of 15 equals log of 15 divided by log of 3. And the rule is you take the log of the argument and you divide it by the log of the base. And they're both in base 10 now. Okay, so for all of these, there's an imaginary 10 there, which we do not need to write, and our calculator automatically understands it. So if I wanted to take log of 12 divided by log of 2, I can get a decimal. Or I can leave this, okay, and this is exact form. So if the problem ever says leave it as an exact answer, you do that, and you have log of 12 divided by log of 2. So today we learned about the product property, the quotient property, and the power property, which all are going to help us next time when we get equations that we have to solve for a variable.